Ancient civilizations mastered water in ways that defy our modern expectations. They built systems not with brute force, but with a profound intelligence we are only now beginning to fully appreciate. This journey uncovers the hidden genius behind aqueducts that ran for miles and desert tunnels that created lush gardens, revealing a forgotten blueprint for survival. You will discover how these ancient methods offer powerful solutions for our own world's growing water crisis. How did societies flourish in the driest deserts using only gravity and stone? What secret knowledge about water management have we lost over the centuries? What does our most vital resource truly reveal about a civilization's greatness? Great cities did not rise by accident. They were anchored to a single, non-negotiable resource, the steady, reliable flow of water. This is the unspoken contract of civilization. A society flourishes or vanishes based on its ability to command this elemental force. Ancient peoples lived by this truth every single day. Their survival was a direct conversation with the rivers, the rains, and the hidden waters deep within the earth. Look at the Empire of Egypt, entirely structured around the predictable, life-giving floods of the Nile. That river did not just provide water, it delivered rich, new soil each year, turning the desert into a breadbasket. Or consider Rome, a city of over 1 million people at its peak, which could never have existed without the mountain springs channeled from dozens of miles away. Water set the rhythm for everything, from planting seasons to religious festivals. This intimate, daily dependence forced a kind of genius. It was not about dominating nature with overwhelming force, but about listening to it, understanding its patterns, and designing systems that worked with the land itself. They had to be clever because their lives depended on it. This foundational relationship with water is what produced the breathtaking engineering we are only now rediscovering. Systems built not with concrete and steel, but with stone, gravity, and a deep, profound wisdom. That ancient genius began with a simple, profound principle, the mastery of gravity. An engineer of Rome or Persia did not look upon a hill as an obstacle. They saw it as a tool. Without a single pump or motor, they coaxed water across vast distances by understanding one unchangeable fact: water always flows downhill. Their challenge was to design a path so perfectly graded that the water would move steadily, never pooling and stagnating, never flowing so fast it eroded the channel walls. This required an almost artistic feel for the land's subtle contours. They used simple tools, sighting poles and water levels, to map a route with a slope so gentle it was often barely perceptible to the naked eye. The Roman aqueducts are the ultimate testament to this. Their channels sometimes descended only a few feet over a mile-long course. This was not about forcing water to go where they wanted, but about finding the path the water itself was willing to take. It was a collaboration with the landscape, a silent agreement between human intention and the laws of physics. This deep environmental intelligence meant their systems were inherently sustainable, powered by the planet itself. They worked with the land, not against it, a lesson in efficiency we are desperately trying to relearn today. This mastery of gravity was only the first step. Ancient engineers also possessed a deep understanding of water's source, designing systems that worked in harmony with the Earth's natural replenishment cycles. Deep beneath the arid plains of ancient Persia, a different kind of water miracle was taking shape. Workers dug not down but inward, carving a gently sloping tunnel from a fertile valley all the way back to the foothills of a mountain. This was a qanat, a subterranean canal that did not force water out of the ground, but instead invited it to flow. The tunnel began deep underground, tapping into a water-bearing layer of rock and gravel at the mountain's base. Because the channel sloped more gently than the water table itself, gravity simply guided the water along this hidden path, allowing it to emerge on the surface many miles away, cool and clean in a desert oasis. The true genius, however, was in its sustainability. A qanat only drew the water that was freely given by the aquifer. It never pumped the source dry. Modern wells, by contrast, can act like straws, aggressively draining an underground reservoir faster than rain can possibly refill it. The builders of the qanat understood something we often forget, that you must live within your water budget. They took only the annual interest, never the principal. This was a profound partnership with the entire hydrological cycle, a patient agreement with the rain, the mountain, and the earth below. It stands as a quiet rebuke to the extractive practices that now threaten water sources across the globe, a reminder that true security comes not from overwhelming a resource, but from listening to its natural rhythm. The Pont du Gard stands today not as a ruin, but as a testament to Roman ambition. This colossal aqueduct bridge in southern France did not just span a river valley, it conquered it, carrying a steady stream of fresh water high above the landscape with a precision that has defied millennia. Its construction was an act of sheer audacity, a declaration that no terrain was too challenging for their vision. But to see this bridge alone is to miss the larger picture. The Roman aqueduct was far more than a stone channel. It was an integrated system, a network of brains and brawn working in perfect harmony. Before water even reached a city, it would often flow through massive sedimentation tanks. Here, the current would slow, allowing silt and debris to settle out, ensuring the water arriving in the metropolis was remarkably clean. For valleys too deep for a bridge, Roman engineers employed a brilliant counterintuitive solution, the inverted siphon. They would lead the water into sealed pipes that plunged down one side of a valley and, driven by the very weight of the water itself, climb up the other side to rejoin the channel. This was not simple gravity flow. It was a masterful application of hydraulic principles, managing immense pressures with lead or stone pipelines. Once inside the city, the water was meticulously managed in distribution tanks like castellums, which acted as traffic circles, directing flow to different urban needs with careful pressure regulation. This entire system supported a way of life we can scarcely comprehend. It fed public baths that were centers of social life, supplied countless fountains that cooled the streets, and delivered water directly into the homes of citizens. This engineering marvel enabled an urban population density that would not be seen again in Europe for over 1,000 years. The scale and complexity of their waterworks reveal a civilization with organizational and technical prowess that was, by any measure, truly ahead of its time. Yet the ambition of Roman aqueducts was matched by a quieter, more intimate form of engineering brilliance, one focused not on grand scale but on the quality of the water itself. Inside the Minoan palaces on the island of Crete, thousands of years before Rome, we find terracotta pipes that reveal a startling concern for purity. These were not simple channels, they were components of an integrated filtration system. Water would first flow into settling chambers, where its speed would drop, allowing heavier silt and particles to drift to the bottom. From there, it would pass through a series of graded filters, layers of charcoal, sand, and gravel, each with a specific job. The coarse gravel trapped larger debris, the finer sand caught smaller particles, and the charcoal, with its porous structure, acted to absorb impurities and even improve the taste of the water. This layered method is the direct ancestor of the slow sand filters we still use in municipal water treatment today, but the Minoans went even further. Some of their systems were designed with cascading steps, creating small waterfalls that aerated the water as it moved. This process introduced life-giving oxygen, which not only made the water taste fresher, but also helped neutralize certain undesirable elements. This entire approach reveals a profound empirical wisdom. They did not need to understand germ theory to observe that cleaner, aerated water led to better health. This was a proactive, deliberate effort to treat water, transforming it from a simple resource into a safeguarded commodity for public well-being. It shows a civilization thinking generations ahead, engineering not just for delivery but for vitality. But that Roman and Minoan brilliance, focused on grand cities and palaces, was not the only path to water mastery. Far from the Mediterranean, in the vast, arid heart of ancient Persia, engineers developed a solution of breathtaking subtlety. They learned to tap the hidden veins of the desert itself. This is the story of the Qanat, a technology so effective it turned some of the world's most unforgiving landscapes into pockets of lush, sustainable life. Imagine a gently sloping tunnel carved by hand through rock and soil, beginning deep underground where it taps a water-bearing layer at the base of a mountain. From this hidden source, the tunnel runs for miles, sometimes for dozens of miles, always maintaining a slope so slight that gravity alone coaxes the water along its secret journey. Finally, the water emerges into the blinding sunlight, not with a violent gush, but as a steady, reliable stream flowing into a desert oasis. This was not a well, which aggressively pumps water up from below. A qanat was an invitation. It simply provided an easier path for the water to follow, allowing it to flow freely to the surface on its own terms. The genius of this design was its profound respect for the natural system. Because it only took the water that the mountain aquifer was willing to give, it never risked draining the source dry. It was a technology of patience, working in perfect sync with the Earth's own replenishment cycle. Building a qanat, however, was a monumental task that bound a community together for generations. Workers dug vertical access shafts down to the tunnel level at regular intervals, using them to remove excavated material and to provide vital air vents. This created the iconic line of circular mounds that still scar the desert landscape today, like a string of beads marking the hidden artery below. The project demanded immense collective effort, precise surveying to maintain the perfect slope over such vast distances, and the courage to work in dark, confined spaces deep beneath the earth. This shared labor naturally gave rise to one of the qanat's most enduring legacies, its cooperative management. The water flowing from the tunnel was not owned by one person. It was a shared resource for the entire community. Elaborate and fair systems were developed to allocate water rights, often based on time, where a farmer might be entitled to the full flow for a specific number of hours each week. This fostered a powerful social institution built on collaboration and shared responsibility, ensuring the life-giving system was maintained and protected for centuries. The qanat stands as a quiet masterpiece of environmental harmony, a testament to how human ingenuity can overcome the harshest constraints not by conquering nature, but by learning to listen to its quietest whispers. Descending into Chan Baori is like walking into the Earth's own cathedral. This is not a mere hole in the ground, but a colossal, inverted pyramid of 3,500 perfectly symmetrical steps, plunging 13 stories deep to meet a dark, placid reservoir. In the blistering heat of Rajasthan, this structure was a miracle of both engineering and empathy. Its primary function was hydrological genius. The vast, stair-stepped walls acted as a massive catchment funnel. When the precious monsoon rains finally arrived, every drop was channeled down these steps, efficiently directing the torrent into the central well for storage. But as the dry season advanced and the water level slowly fell, the steps revealed their second brilliant purpose. They formed a constantly adjusting staircase, always providing access to the life-giving water, no matter how far it receded into the earth. And all the while, the sheer depth and intricate labyrinth of the structure kept the water reservoir in near perpetual shade, dramatically reducing loss to evaporation under the relentless sun. Yet to call a stepwell just a water source is to miss its soul entirely. It was a vibrant, subterranean community center, a sacred temple, and a natural air conditioning system. The temperature could be dramatically cooler at the bottom, offering a vital refuge from the scorching world above. People gathered here not only to collect water but to socialize, to pray in the ornate shrines carved into the walls, and to simply exist in a space of profound beauty and cool tranquility. This was a complete fusion of utility, artistry, and spiritual life. The stepwell did not simply store a resource. It wove water directly into the cultural and social fabric of the community, making its management a shared, sacred duty. It stands as a powerful testament to a holistic vision, where solving a practical problem did not mean sacrificing beauty or community, but rather enhancing them both. High above the Peruvian desert, the famous Nazca lines are not the only marvel etched into the earth. Scattered across this stark landscape are strange, spiraling stone formations that descend into the ground. These are the Puquios, and for the ancient Nazca people, they were the very source of life in one of the most arid places on the planet. While the Romans built towering aqueducts to cross valleys, the Nazca engineered a solution that worked from within, a system that breathed. The spiral opening of a Puquios was far more than an architectural flourish. It functioned as a clever wind catcher. The desert surface bakes under a relentless sun, but the underground tunnels, tapping into a distant aquifer, remain cool and stable. This temperature difference created a constant, natural airflow. Hot surface air would rush down the spiral opening, and in doing so, it pulled the cooler, moisture-laden air from the aqueduct tunnels up and out. This constant circulation did more than just ventilate the tunnels. It actively drew groundwater toward the surface through a process of evaporation and condensation, effectively creating a wind-powered pump. This was passive technology at its most brilliant, a system with no moving parts, no fuel requirement, that harnessed the desert's own harsh conditions to deliver a steady water supply. It was a perfect partnership with the environment, using the sun's heat and the wind's force to achieve what would have otherwise required immense labor. This ingenious network of breathing aqueducts transformed the Nazca Desert. It fed a system of irrigation canals that turned barren soil into fertile fields, sustaining a population large enough to undertake the colossal cultural project of the Nazca Lines. Those immense geoglyphs, only fully visible from the sky, were made possible by the hidden, spiraling waterworks below. The lines are the art, but the Puquios were the life support system, a testament to a culture that did not fight its environment, but learned to listen to its subtle rhythms and harness its invisible forces. The true mastery of ancient water systems lies not just in their grand scale, but in their intricate adaptation to the land's own logic. High in the rose-red cliffs of Petra, the Nabateans performed a miracle of survival, carving a metropolis from stone in one of the world's most unpredictable deserts. Their secret was not fighting the scarcity of water, but in capturing its every fleeting opportunity. They learned to read the desert like a book, understanding that its greatest threat, the sudden, violent flash flood, was also its most precious gift. With astonishing precision, they engineered the entire city to become a giant water catchment system. They carved channels directly into the cliff faces, diverting the torrential runoff from rare storms away from the city's heart and into a vast, hidden network of underground cisterns and reservoirs. Think of the Sikh, the magnificent narrow canyon that serves as the main entrance to Petra. To a visitor, it is a breathtaking corridor of rock. To a Nabatean engineer, it was a managed riverbed, its walls etched with channels that tamed flash floods and guided water to where it was needed most. They even constructed massive dams to control the flow and capture sediment, creating a buffer against the long, dry seasons. This was not a passive system. It was an active, city-wide collaboration with the climate, a dialogue with the rain. Every paved street, every courtyard, every rooftop was part of the design, all sloping to direct water into the subterranean storage that fed the city. This intricate web of conduits and cisterns allowed Petra to flourish as a wealthy nexus of trade, supporting a population of thousands in the heart of a barren landscape. It stands as a powerful testament to a simple, profound truth that in the desert, water is not found, it is made, collected drop by precious drop through foresight and brilliant design. Deep within the Cambodian jungle, the temples of Angkor rise from the green canopy as monuments in stone. But the true wonder of this place lies not just in what stands above the ground, but in what was engineered across it. The Khmer Empire was a hydraulic civilization, a society whose entire existence was orchestrated around the capture and release of water. Their challenge was the monsoon, a season of ferocious abundance followed by months of punishing drought. The Khmer solution was to build a landscape-scale sponge. They constructed immense man-made reservoirs called barrays, so vast they resembled inland seas. The largest of these, the West Barray, stretches 5 miles long and over a mile wide, an expanse of water held back by earthen banks that still defy erosion centuries later. This was not a solitary structure. It was the heart of a sprawling network of canals, dikes, and moats that interconnected to form a single, colossal machine for managing the monsoon's gift. When the rains came, this system would channel the floodwaters, filling the barrays and saturating the earth. Then, during the long dry season, the stored water was gradually released through a carefully calibrated network of canals to feed an immense, intensive rice agriculture. This system transformed seasonal scarcity into year-round abundance, enabling the Khmer to support an urban population that may have approached 1 million people, a scale unmatched in the pre-industrial world. For centuries, we could only glimpse the edges of this achievement. The jungle had reclaimed much of the empire, hiding its full scope, but recent LIDAR technology, which uses laser pulses to map the ground beneath dense foliage, has ripped away the green veil. The scans reveal a breathtakingly planned metropolis, a grid of canals and roads, field systems and temples, all laid out with a geometric precision that speaks of central authority and profound foresight. Water was the empire's circulatory system, and every channel had a purpose. It irrigated the rice paddies that fed the populace. It provided transportation routes connecting distant parts of the kingdom. And it held deep symbolic meaning, with the moats around temples like Angkor Wat representing the mythical oceans surrounding the home of the gods. The Khmer did not just build with water, they wove it into their cosmology, creating a world where engineering, urban planning, and spiritual belief were inseparable. This was not merely a water system, it was a conscious recreation of a sacred, ordered universe, written not on parchment, but across the land itself with canals and reservoirs. While the Khmer were reshaping entire landscapes, a different kind of water wisdom was flowing within the walls of a Bronze Age palace. At Knossos on the island of Crete, the Minoans engineered a quiet revolution in daily life, one that would not be matched for thousands of years. Deep inside the labyrinthine palace, they installed the world's first known flush toilets. This was not a simple pit in the ground. It was an integrated system of terracotta pipes, carefully laid with a downward slope, and channels that used gravity to whisk waste away from living quarters and into a larger sewer network. Imagine the simplicity and the sheer brilliance of that act. With a pour of water from a container, the waste was gone, flushed from the palace to a place where it could no longer threaten health or comfort. This was a profound leap in urban sanitation. In an age where most of the world lived in much closer proximity to their own waste, the Minoans had devised a way to create a clean, hygienic separation. This system was a powerful public health measure long before the concept even had a name. By efficiently removing human waste, they were undoubtedly reducing the spread of waterborne diseases like typhoid and cholera, plagues that would ravage less advanced societies for centuries to come. Their advanced hydraulics were not reserved for grand fountains or religious rituals alone. They applied this same engineering principle to the most mundane, yet most critical, aspect of urban living. It reveals a society that valued not just monumental architecture, but the quality of the environment in which its people lived and worked. This concern for hygiene and comfort, for managing the entire water cycle from pristine delivery to efficient removal, demonstrates a holistic standard of living that truly rivals our own. That same water flowing through a qanat or a Roman aqueduct was never just a physical resource, it was a social one, and the brilliance of ancient societies extended far beyond their engineering, into the very fabric of their laws and governance. In ancient Mesopotamia, the lifeblood of civilization was the Tigris and Euphrates, but its fair use was guaranteed by words baked into clay. Scribes meticulously recorded complex water rights on tablets, establishing the world's first known legal codes for allocation. Who got water when and for how long was not left to chance or power alone. These were formal rules designed to prevent the farmer upstream from starving the farmer downstream. They created systems for dispute resolution, so that conflicts over this precious commodity could be settled with evidence and testimony, not with violence. This was a profound realization, a societal leap. A perfect irrigation channel is useless if neighbors are fighting over its output. From the mountains of the Andes to the plains of Mesopotamia, cultures independently arrived at the same truth, that technology alone is never enough. The most advanced water system in the world will collapse without fair governance, without the social cooperation and structured administration to manage it for the common good. These ancient systems were often models of pragmatic equity. Water might be allocated based on demonstrable need, the size of a family's fields. It could be granted through seniority, respecting the rights of those who had worked the land the longest. Or it could be tied directly to community contribution, where your share of water reflected the labor you invested in maintaining the canals and reservoirs. This was not communism, nor was it pure capitalism. It was a localized, customized system of resource distribution designed to maintain stability and prevent the internal conflicts that could destroy a community. This early development of water law reveals a deep, sophisticated understanding of human nature. They knew that sustainability is a two-part equation, requiring both the technical mastery to harness water and the social contract to share it peacefully. It highlights a timeless principle we are still grappling with today, that our relationship with water is ultimately a reflection of our relationship with each other. This reliance on shared rules reveals another layer of ancient genius, a strategic foresight that looked beyond fair distribution to the very survival of the system itself. Ancient water networks were masterclasses in resilience, built not on a single point of failure, but on a foundation of deliberate redundancy. Rome itself did not depend on one aqueduct, but on 11. If a landslide blocked one channel or an enemy army cut its supply, the city had other, independent conduits bringing water from different mountain sources. The entire urban population was not held hostage by the vulnerability of a single pipe. This principle of diversification extended to the very nature of the water they collected. A single city might draw from perennial springs for its base flow, capture and store rooftop rainwater for immediate household use, and maintain access to local wells for groundwater as a final backup. This created a robust, multi-pronged approach to water security. It was a pragmatic strategy for managing the inherent uncertainty of their world, a world of droughts, earthquakes, and conflict. By not placing all their bets on one source, they built a system that could absorb shocks and withstand stresses that would have crippled a more centralized design. This ancient insight feels startlingly modern. In our own era of climate change, where once reliable rainfall patterns are becoming unpredictable, the wisdom of a diversified water portfolio is more critical than ever. It is a lesson in risk management written in stone and clay, teaching us that true security does not come from a bigger pipe, but from a smarter, more interconnected web of supply. But the ancient conversation with water went far deeper than survival alone. It reached into the very air people breathed, transforming the experience of daily life. In the heart of a sun-scorched Islamic garden, the presence of water was a deliberate act of climate engineering. A central, channeled stream would flow through a shaded courtyard, branching into narrow rills that fed serene pools and fountains. This was not merely decoration. Each droplet that splashed and each surface that was wetted contributed to a powerful cooling effect. As the water evaporated, it drew the necessary heat from the surrounding air, creating a pocket of refreshing coolness in the middle of a desert afternoon. This was passive cooling at its most elegant, a system with no moving parts that turned the sun's own intensity against itself to make a sanctuary of comfort. 1,000 miles away, Roman aristocrats enjoyed a similar luxury woven directly into their villas. They built intricate networks of channels called specus right into the thick walls of their homes. Fresh, cool water from a distant aqueduct would flow continuously through these hollow spaces, absorbing the heat from the sun-baked stone before exiting on the other side. The walls themselves became a heat exchange system, steadily radiating coolness into the interior rooms. Think of it as a primitive but remarkably effective form of air conditioning, all powered by gravity and the steady flow of their water network. This integration of water and architecture reveals a sophisticated understanding of microclimates. Ancient engineers were not just building structures, they were crafting environments. They knew that by strategically placing water features, from a simple courtyard fountain to a wall cooling channel, they could alter the humidity, temperature, and airflow of a small area. This made dense urban spaces in arid regions not just habitable, but genuinely pleasant. This approach represents a holistic vision of water management, where its purpose expanded from a biological necessity to a tool for enhancing health, comfort, and the overall quality of urban life. They saw water not just as a resource to be consumed, but as a medium to shape the world around them. High on a mountain ridge, the stone channels of Machu Picchu still sing with water. This lost city of the Incas is a masterpiece of hydraulic engineering, a system so perfectly integrated with the peak it crowns that it feels less built and more grown. Without a drop of mortar, the Incas carved and fitted stone canals with such precision that mountain spring water has flowed through them uninterrupted for over 5 centuries. The gradient of each channel was calculated with an artisan's eye, ensuring a steady, gentle flow that would neither stagnate nor erode the sacred stone. They even incorporated natural filtration, using layers of gravel and sand within the channels to screen out sediment, delivering remarkably clean water to the city's fountains and baths. But this was more than just clever plumbing. The entire system was designed as an extension of the mountain itself, engineered to withstand the two great forces of the Andes, the torrential rains of the wet season and the constant threat of earthquakes. The channels were not rigidly locked in place. Instead, their dry stone construction allowed them to flex and shift during a tremor, settling back into place without cracking, a simple yet brilliant solution to a potentially catastrophic problem. This reveals a profound geological intelligence, an understanding that to build for eternity, you must work with the land's own restless nature. Every element, from the spring's source to the final fountain, was woven into the Incan spiritual worldview. Water was not a utility, it was a sacred thread connecting the city to the mountain gods, the Apus. The engineering was an act of reverence, a physical prayer that harmonized human need with the divine landscape. The water channels were as much a part of the temple complex as the altars themselves, a flowing reminder that for the Inca, there was no separation between the practical and the spiritual, between quenching a thirst and honoring the earth. The floating gardens of Tenochtitlan offer a vision of a city cradled by its own food supply. Gliding through the canals of the Aztec capital, you would have seen not just water and stone, but a living, breathing agricultural machine. These were the Chinampas, long, rectangular islands that transformed the shallow lake bed into the most productive farmland in the ancient world. To build them, artisans wove giant rectangular frames from reeds and stakes, anchoring them to the lake bottom. They then piled layer upon layer of nutrient-rich mud from the canal beds, alternating with thick mats of decaying vegetation. The result was a buoyant, incredibly fertile plot of land, permanently irrigated by the capillary action of the surrounding water. The roots of the crops planted here always had access to moisture, creating a self-watering system that needed no rain, but the genius did not stop at simple irrigation. The Chinampas were a perfect loop of sustainability. Aquatic plants and nutrient-rich muck dredged from the canals were constantly added to the plots, replenishing the soil and eliminating the need for fallow periods. This continuous enrichment prevented the soil exhaustion that plagued conventional dryland farming. In turn, the carefully managed canals between the islands teemed with life, providing fish and a habitat for waterfowl, adding valuable protein to the Aztec diet. This was not farming that conquered a wetland, it was farming that became the wetland, an agro-ecological masterpiece that produced multiple harvests each year. This hyper-efficient system fed an immense urban population, turning Tenochtitlan into a marvel of pre-Columbian civilization that stunned the Spanish conquistadors. It stands as a powerful example of how a society can flourish not by overpowering an ecosystem, but by weaving itself so intricately into the environment that the line between the natural and the man-made simply disappears. This reverence for water flowed directly into the heart of their spiritual lives. The river was not merely a source of irrigation, it was a living goddess. The spring was not just a water source but a portal to the divine. Across the ancient world, from the banks of India's Ganges to the misty groves of the Celtic peoples, water was understood as a sacred element, a force of both physical creation and spiritual cleansing. This was a fundamental shift in perspective. Water was not a commodity to be controlled, but a divine gift to be honored. In India, the Ganges River is personified as the goddess Ganga, descended from heaven to purify the earth and the souls of those who bathe in her waters. For the Celts, certain springs and wells were seen as thresholds to the otherworld, places where one could commune with deities and ancestors, their waters possessing healing properties. This spiritual relationship fostered a powerful, inherent sense of responsibility. You do not pollute the home of a goddess. You do not carelessly waste a gift from the gods. This sacred world, you created a powerful cultural enforcement mechanism for conservation. Rituals and festivals were often tied to the health of the water source, and the custodians of these sites, whether priests or a designated community elder, held a revered position tasked with protecting its purity. This intertwining of the practical and the sacred created a powerful feedback loop. The belief that a divine presence resided in the water ensured its careful management, and the resulting, sustained flow of clean water reinforced the power of the belief. It was a holistic system where mythology served as the ultimate environmental protection agency. This stands in stark contrast to our modern, often purely utilitarian view, where water is a chemical formula, H2O, a substance to be processed, piped, and billed. We stripped away the sacred, and in doing so, we may have lost the most powerful incentive for its protection. The ancient world understood that to care for the water was to care for the soul of the community itself. A water system, no matter how brilliantly designed, is only as resilient as the community that maintains it. That steady flow from a qanat or a terraced mountain spring was not a gift of perpetual motion. It was the product of relentless, shared effort. Silt slowly accumulates in the bottom of a tunnel. A stone channel on an Incan hillside can be cracked by a falling rock. These were not systems you could build and simply forget. They demanded constant, watchful care, and this necessity forged a powerful culture of stewardship. The very survival of the village depended on the clear flow of water, so every able person had a role to play. The annual cleaning of a qanat was a monumental event. Teams would descend down the vertical access shafts, passing baskets of silt hand over hand back up to the surface, clearing the artery so the water could run freely for another year. In the Andes, families would gather to repair the stone conduits that fed their terraces, knowing that a single blockage could mean the failure of an entire season's crops. This was not a chore imposed by a distant authority. It was a collective responsibility, a direct investment in their own survival. This shared labor did more than just maintain the physical infrastructure. It was the primary vehicle for passing critical knowledge from one generation to the next. A grandfather would show his grandson how to feel for the correct slope of a channel just by watching the waters flow. A mother would teach her daughter how to read the subtle signs of silt buildup. The engineering principles were not written in books. They were learned by hand and passed down through practice, making the entire community the living library of its own water wisdom. This created a powerful, self-reinforcing cycle. Because everyone had invested their own sweat in maintaining the system, everyone felt a deep, personal stake in its health. You would not stand by and let a neighbor waste the water you had labored to bring to the village. This vested interest naturally gave rise to the fair allocation rules and cooperative governance we saw earlier. The social structure and the physical infrastructure were two parts of a single, sustainable whole. The system endured for centuries not because the stone was impervious, but because the culture of care was unbreakable. Our modern water systems are a triumph of power and scale, moving oceans of water across continents at the flick of a switch. Yet this power comes at a cost, creating a paradigm fundamentally opposite to the ancient one. We have replaced gravity with gigawatts, trading the quiet patience of a qanat for the relentless hum of electric pumps. Our networks are vast centralized webs, where a single treatment plant serves millions and a break in a main pipeline can paralyze an entire city. This centralized model creates a critical vulnerability, an absolute dependence on a constant, massive energy supply. When the power fails, the water stops. Ancient systems, in contrast, were decentralized by nature. A Roman aqueduct was a linear channel, not a pressurized grid. A blockage in one section might affect its terminus, but it would not collapse the entire network. Their resilience was built into the design, a redundancy of simple, independent parts. The modern approach often treats water as a sterile industrial product, to be chemically purified at a central plant and then forced through concrete veins. We separate water from its environment, building levees to fight rivers and paving over the absorbent ground that would naturally replenish aquifers. The ancient model was one of integration, working with the landscape's own logic to slow, spread, and sink water into the earth. They built sponges, we build chutes. This comparison forces a difficult question. Is technological superiority measured solely by the volume of water we can move, or is it also measured by the elegance, resilience, and sustainability of the system? In an age of climate uncertainty and energy constraints, the ancient focus on low-energy, decentralized, and environmentally attuned solutions no longer looks like a relic. It looks like a vital blueprint for a more secure future. That deep, place-based wisdom was not born from abstract equations. The ancient master of water worked with a different kind of science, one written in the language of mud, stone, and seasonal flow. They did not possess our textbooks on fluid dynamics or our sophisticated computer modeling software. Their genius was empirical, forged over generations by simply watching, testing, and remembering. An engineer in Mesopotamia did not calculate the optimal slope for a canal using advanced mathematics. He learned it by walking the land with his father, observing which channels flowed freely and which ones clogged with silt or ran dry too quickly. They built a small section, watched how the water behaved during the next flood season, and then adjusted. Failure was not a catastrophe, it was a lesson etched into the earth itself. A collapsed canal bank taught them about soil stability. A tunnel that collapsed revealed the weakness of a particular rock layer. This was a slow, iterative process of trial and error, where every mistake was a data point that refined the community's collective understanding. Over centuries, this accumulated practical knowledge became a kind of localized genius. They knew that in this specific valley, a slope of 1 finger's width drop for every 10 paces of length was perfect. They discovered that layering charcoal between river sand and gravel created the clearest drinking water, long before anyone understood the concept of chemical filtration. They could read the landscape like a map, knowing that a certain alignment of trees or a particular type of vegetation often signaled a hidden spring just below the surface. This was intelligence deeply rooted in intimacy with a place. A Roman engineer from Britain would have been lost in the deserts of Petra, and a Nabatean watermaster would have been puzzled by the monsoon rhythms of Inca. Each solution was exquisitely tailored to its unique environment, the product of a long, unbroken conversation between a people and their specific patch of earth. This stands in stark contrast to much of modern engineering, which often seeks universal, one-size-fits-all models. We pour concrete channels based on standardized formulas, sometimes with devastating consequences for local ecosystems. The ancient approach reminds us that true sustainability might require us to listen as much as we calculate, to value the deep, slow knowledge that comes from belonging to a place for a very, very long time. This ancient wisdom is not a forgotten relic, it is a vital blueprint for our present crisis. Today, millions face the very real threats of water scarcity and contamination, challenges that these old masters understood intimately. Their fundamental principles offer a surprisingly direct path forward. Take the simple, profound act of rainwater harvesting. We pave over landscapes, treating rainfall as a nuisance to be drained away as quickly as possible. The Nabateans of Petra, by contrast, saw every raindrop as a treasure to be captured. Modern cities are now rediscovering this logic, creating green roofs and permeable pavements that allow water to seep back into the ground, replenishing aquifers instead of overwhelming sewers. This mimics the ancient strategy of working with the water cycle, not against it. Then there is the critical issue of groundwater. Our modern approach often involves drilling deeper and deeper wells, aggressively mining ancient aquifers that took millennia to fill. The Persian Qanat offers a powerful alternative, a model of sustainable extraction that only draws what the earth can naturally replenish. We can apply this wisdom by deliberately recharging our own groundwater, using managed systems to redirect floodwaters into the earth, essentially banking water for the dry seasons ahead. This shifts our relationship from one of extraction to one of stewardship. The ancient reliance on decentralized, community-managed systems is perhaps the most relevant lesson of all. Our vast, centralized water grids are incredibly efficient, but also incredibly fragile. A single point of failure can leave entire regions without water. The ancient model of local springs, cisterns, and small-scale networks creates resilience through diversity. It empowers communities to manage their own most precious resource, fostering the same culture of care and direct responsibility that kept qanats flowing for centuries. This is not about abandoning modern technology, but about augmenting it with ancient intelligence. By blending our powerful engineering with their profound ecological wisdom, we can build systems that are not only more resilient to climate change, but also more equitable. It is about creating a world where water security is not a privilege for some, but a shared, carefully managed reality for all. The path to a water-secure future may very well be found by tracing the channels of the past. The full genius of these ancient water masters has remained hidden for centuries, buried under jungle canopy or visible only as scattered fragments. But now, a technological revolution is pulling back the veil. Archaeologists are using laser eyes to see through dense forests, revealing entire lost cities and their hydraulic hearts. This is LIDAR technology, a system that fires millions of laser pulses from an aircraft down to the ground. By measuring how long each pulse takes to return, it creates an exquisitely detailed three-dimensional map of the surface below, effectively digitally stripping away every tree, bush, and vine. What emerges from this digital deforestation are the ghostly outlines of civilizations we never knew existed on such a scale. In the jungles of Cambodia, LIDAR scans did not just find a few more temples around Angkor. They revealed a vast, low-density metropolis covering an area the size of Los Angeles, crisscrossed by a mind-bogglingly complex grid of canals, reservoirs, and elevated roads. This was not a city in the way we imagine it, but a carefully engineered water landscape, a sprawling hydraulic machine designed to manage the monsoon on a regional scale. Every channel had a purpose, from irrigation and transportation to flood control and ritual. These scans prove the Khmer Empire was not just a collection of grand temples, but a continent's first and most extensive water-powered state. Across the globe in Central America, similar laser surveys are rewriting Maya history. We once pictured their cities as isolated ceremonial centers in a pristine jungle. LIDAR reveals a different truth, a densely populated and dramatically altered environment. The images show not just pyramids, but extensive networks of wetland farming canals, terracing on hillsides to control erosion, and intricate systems of reservoirs and dams that turned seasonal swamps into perennial farmlands. They were not merely surviving in their landscape, they were actively and intelligently re-engineering it to support millions of people. This is a constant, thrilling revision of our own understanding. Each new flyover with a LIDAR sensor, each new analysis of satellite imagery, acts like a page turning in a book we have only just begun to read. It confirms that the hydrological achievements we once considered isolated marvels were in fact part of a global tapestry of water wisdom, a tapestry whose full pattern and brilliance we are only now starting to truly see. This persistent myth of a straight line of progress crumbles when faced with the evidence. We are taught to believe that history marches forward in a neat, upward trajectory, where each generation surpasses the last in every conceivable way. Yet the existence of these brilliant ancient waterworks presents a profound contradiction. In many crucial respects, their solutions were demonstrably more sustainable and inherently more resilient than the high-energy systems that eventually replaced them. Think of the quiet, gravity-fed Qanat that sustained a desert community for 1,000 years, compared to the modern well that can drain an aquifer in a single generation. Our industrialized networks move more water faster, but they do so at a tremendous cost in energy and vulnerability. This is not a story of primitive versus advanced. It is a story of different philosophies, one focused on harmony and long-term survival, the other on immediate power and scale. This realization delivers a necessary dose of humility to our modern technological arrogance. It forces us to ask a difficult question. What exactly do we mean by progress? Is it merely the invention of new gadgets and more powerful machines? Or is it the cultivation of wisdom that ensures a society can endure for centuries? The ancient world mastered the latter, creating systems that were not just engineering feats but acts of profound foresight. Their legacy suggests that true advancement is not a relentless forward charge, but a cyclical process of learning, forgetting, and sometimes desperately needing to rediscover what was once known. It opens the door to a richer, more nuanced view of history, one where knowledge is a fragile treasure that can be lost for millennia, waiting patiently in the desert sand or the jungle floor for us to find it again. The water that flowed through an ancient city did more than just quench thirst. It shaped the very soul of the urban space, transforming functional infrastructure into public art. In Rome, water was a spectacle. It cascaded from monumental fountains, each one a declaration of civic pride and imperial generosity. These were not hidden pipes leading to private taps. They were roaring, central features in forums and plazas, where the sound of falling water masked the city's noise and created islands of cool tranquility. People gathered here to socialize, to conduct business, and simply to enjoy the display. The water itself was the main attraction, a constant, visible reminder of the empire's power to command nature for the pleasure and well-being of its citizens. 1,000 years later, and a continent away, Moorish architects perfected this philosophy. In the palaces of Alhambra, water was not just seen, it was used to frame the entire experience of a place. Long, narrow channels mirrored the archways and columns, doubling the architecture in a shimmering, liquid reflection. Still pools captured the sky, turning a courtyard into an open-air canvas that changed with the light. The gentle, melodic sound of water trickling through rills was composed to be as important as the visual symmetry. This was a multi-sensory masterpiece where the practical need for water was seamlessly woven into an environment designed for contemplation, beauty, and sheer delight. This integration of function and form created a profoundly different kind of city. It was an environment where the most essential utility was also a source of recreation, spiritual calm, and artistic identity. The infrastructure did not lurk beneath the streets. It danced and sparkled in the sun at the very heart of public life. It made the city not just a place to live, but a place to be inspired. This ancient principle that our vital systems can and should elevate the human spirit is finding new life today. Modern urban planners are rediscovering the value of daylighting buried streams, of integrating water features into parks and squares, and of treating rainwater not as waste but as a design element. The lesson from Rome and Granada is clear. When we celebrate water instead of merely piping it, we build cities that are not only more sustainable, but infinitely more human. Even with all we have uncovered, profound mysteries still ripple beneath the surface of ancient water science. High in the Andes, the ruins of Tiwanaku present a puzzle that defies simple explanation. Here, builders moved blocks of sandstone weighing more than 100 tons across miles of rugged terrain, fitting them together with such precision that not even a razor blade can slip between the stones. This monumental effort was not for a temple alone, but for a complex hydraulic system of canals and reservoirs integrated directly into the architecture. How a society without the wheel or draft animals achieved this feat of logistics and stonework remains one of archaeology's most enduring enigmas. The water channels themselves are masterpieces of precision, but the method for transporting and placing their colossal components is a secret the site stubbornly keeps. Across the world in ancient China, another mystery flows from the past. Historical texts speak of dragon bones, intricate water-lifting machines that could raise water from rivers to irrigate high fields. Scholars have proposed designs based on chains of square pallets or rotating paddle wheels, but the exact mechanics and appearance of these devices are lost to time. Were they powered by human labor, by oxen, or even by the current of the river itself? Their full design and revolutionary impact remain just out of reach, a ghost of an engineering solution we can only partially reconstruct. For every system we confidently map, there are countless questions about the transfer of knowledge. How did the core concept of the Qanat spread so widely from Persia, appearing in distant cultures? Was it through trade, migration, or did multiple societies independently arrive at the same brilliant solution to desert survival? The specifics of this hydrological dialogue are erased. These are not trivial gaps, they are fundamental silences in the story of human ingenuity. The ongoing search for answers is what keeps this field vibrantly alive. Every new excavation, every reinterpretation of a worn text has the potential to shatter our assumptions. The most exciting possibility is that the solutions to these ancient mysteries might still hold practical value for us. Understanding how the dragon bones truly worked could inspire low-energy irrigation for rugged terrain today. Deciphering how Tiwanaku's builders managed their water pressure without metal tools could reveal new principles for gravity-fed distribution. Our ancestors may yet become our teachers, their deepest secrets waiting to offer solutions for the water-challenged world we inhabit now. A clear pattern runs through every stone channel and desert tunnel we have explored. Ancient water systems were not crude experiments. They were mature, sophisticated technologies refined over centuries of intimate interaction with the natural world. They achieved a level of sustainability we are now scrambling to reinvent. Their genius lies in a few core principles we have largely abandoned: the unwavering faith in gravity over gasoline, the commitment to taking only what the earth could replenish, and the understanding that a water system's true strength comes from the community that maintains it. These are not historical curiosities. They are a blueprint for our own survival in an era of deepening droughts and unstable climates. The path forward does not lie in pouring more concrete or burning more energy to force water where it does not want to go. It lies in rediscovering that ancient art of listening to the landscape, of designing with nature rather than against it. This is the ultimate lesson from the past, a call to humbly look backward for forward-thinking solutions, to weave timeless wisdom into the fabric of modern innovation. If this journey into the heart of historical hydraulics has shifted your perspective, we would love to hear which ancient system resonated most with you. Share your thoughts in the comments and join us as we continue to uncover the profound mysteries of our shared past.